like this, then what you get is you just get what's called a shallow copy. So you have two things that point to the same object. So I have a picture here that when I say copy equals E, then copy and E both point to the same thing. That's just a copy of the pointer. Is that bad or is it good? Well, a lot of times that's actually just fine because that's what you normally do. Right? You pass something to a method, some object, you just give a reference. The thing is, of course, that when you do that, the reference can be used to mutate the original object. Sometimes you don't want that, and in that case, you would want to make a copy of the object so that the copy lives on distinctly. The other reason, as we'll see later, there's another reason for making a copy. That is if you want to transport an object from one virtual machine to another. But right now we live in one virtual machine, and yet we feel the need to make a copy. So there's a clone method that you can use to make a copy. There's one place so far that you've seen where I've put that to good use, and that is in these graph editors, in Violet or the graph editors that you've been seeing in the homework and the exam. The toolbar has objects, one for each thing that you might want to put onto the graph, and whenever you click on it, then it actually makes a clone and puts the clone right onto the graph. So in Violet, when I click here on this thing, and now I click here, a clone of the object in here is made. Clone, clone, clone. All right. Now how do you make a clone? There is a clone method, and you just call it. It's declared in Java-Lang object, so its return type is object, and so then here I'm casting it to employee because the clone of employee is, of course, an employee. So the intent of cloning is that you get a new object that has an identical information in it, but where it lives in a separate object, so that if you mutate one, then the other one is unaffected. Now, it turns out that cloning is kind of tricky, and because it's kind of tricky, object.clone is defined as protected. Every class inherits clone, and they say they want to make sure that users of a class can only call clone if the designer of the class agreed that cloning makes sense. So the first thing that I need to do when I want to allow cloning of my objects as a designer of a class, I need to re-implement object.clone to be public. That way anyone can use it. When doing that, I can, of course, return super.clone and get the object clone. I'll have to do a little bit of extra work that you see in the next slides, but it is the right approach. Now, what super.clone does is it makes a new object of the same type, of type employee, and it copies over all of the fields. So if I started out, if I called clone on this thing here, it makes another one that looks just like this, copies this field, copies that. That's what it does. Now, weirdly enough, object.clone will not actually clone any object. Even if you made the clone method protected and then you call super.clone, there's a second independent safeguard in there to see whether the programmer knows what they're doing. And that is the clonable check. So there is an interface clonable with no methods. Clone is not defined in this interface. It's defined in Java-Lang object. But you still have to implement it. The object.clone method has a test somewhere in its guts where it checks whether the object that's being cloned belongs to a class that implements clonable, and otherwise it throws a clone not supported exception. So if you want to participate in cloning, you need to make sure that your class implements clonable. So we have that here. The class employee implements clonable. And now here is an implementation of clone. We return super.clone, and we catch the clone not supported exception. Why do I have to catch it?
Because it declares it throws it.
Because clone is declared not to throw any exception, right? When I override it, I also can't throw any exception, so I'm forced to catch it. This is an exception that will not happen because I've just declared employee as clonable, but I still have to somehow deal with it. Yeah?
I thought you said it needed to be protected. So
No, it's defined as protected, but I'm redefining it as public so that the public can use it.
okay.
I can make it more visible. In a subclass, I can make a method more visible. I can't make it less visible.
Okay.
Because the superclass says it's public, it's protected, and I can't make it private.
Mm-hmm.
But I can make it more visible and thereby allow everyone to participate in the goodness of clone. So now anyone can call the clone method. It's going to do exactly the same thing as object.clone, namely clone all the fields, and this exception will not be thrown, and so this null here will not actually happen. Now, I say that, but how do I really know that this exception will not be thrown? Because it's, of course, possible for someone to form a subclass of employee, say manager, and maybe manager does something that interferes with the cloning to actually still throw that exception. That could happen. And it's up to me to figure out what do I want to do in that case. There's various things that I could do. And maybe the smarter thing to do would be to declare that clone, let's see, can I declare that clone throws a clone not supported exception? No, I can't do that. But I could have it throw an unchecked exception maybe. But that's something that they haven't really thought through all that well. Now, here is why the cloning is considered to be a potentially dangerous thing. Let's say that I have an employee that doesn't just have a name and a salary, but also a reference to a mutable object. So hire date, if I use one of those more modern time classes, then this problem wouldn't occur. But let's say that hire date is an old-fashioned Java util date. That is a mutable class, so it is possible for anyone to mutate a date. Here's what happens when object.clone clones my employee. It copies the name, it copies the salary, it copies the hire date. When I say copies, it just copies the references. That's what it does. It does what's called a shallow copy. Now, sharing the name is not a problem. Why?
Strings are immutable.
Strings are immutable, and no one will ever really know whether this is the same object or whether there's two distinct objects with the same contents. They're always going to have the identical contents. There's no way of changing the string. So it's never a problem to share immutable objects. But sharing mutable objects is a problem because if someone messes with this hire date of this one here, for whatever reason, to get themselves a bigger pension or something, then the other one will also be affected because it points to the same thing. So what cloning really should do is it should somehow know which of these objects are immutable and which of them are mutable, and it should then recursively clone the mutable ones. Then the objects would be truly different. That's too difficult to be done mechanically, so the programmer has to do it. Yes?
Isn't there an immutable interface in Java?
No, there isn't. So that's a good question whether there should be some way of tagging that an object is mutable or immutable. There's nothing like that in Java. And maybe that's what would be an interesting question for a programming language to do that. But the other thing that they could do is they could just recursively clone everything. But that could get expensive, right? Because then you would clone things that don't need to be cloned. So the Java designers said way back when, this is difficult stuff. It doesn't happen all that often. We're going to make the programmer do it. Here's what the programmer has to do. So you call super.clone, and then you manually clone the hire date and assign that over, and now you have a deep copy. You don't need to worry about the string because strings are immutable. And that's just what you have to do. It's a kind of busy work. It's not the only busy work that there is in Java. Remember, when you want to implement toStrings or equals or hash code, you have to do some amount of busy work. And here it's the same thing. Yes?
Hire date isn't declared anywhere, is it? When you say cast
because this hire date is declared, it's an instance variable of employee. Employee has 3 fields. Name, salary, and hire date.
Okay.
So this hire date is the hire date
Makes
of
sense.
this.
Okay.
So I could say this dot hire date.
Okay,
If
thank
you
you.
like.
Yes, sorry.
So here's the picture of that, where after the cloning, we now have two dates, the original date, the date of the clone, but we never bothered to clone the immutable string, so that one is still shared. So the programmer has said that's the optimal way of doing cloning. The programmer has implemented it in this way, and that's what you need to do. So now, what's a little bit unfair, I feel, about how this whole thing is done. Object.clone says, I'm super paranoid about cloning. Cloning has all of these dangers, programmers might mess this up. So therefore, I'm doing two things. Number one, I'm saying clone is protected. And number two, I say, I'm only going to clone things that are clonable. So there's actually three things. And the third one is, I'm throwing a checked exception. So, unfortunately, you don't have that luxury. Manager.clone must be defined if manager adds mutable fields. If manager.clone simply relies on object.clone, on employee.clone because that is defined, then maybe some mutable stuff doesn't get cloned properly. So, and there's no other way for me to signal that to anyone. And so some people say that you should not actually override clone. You should make your own method and maybe make that method protected. That way you regain that protection. Another thing that you could do is you could say, if you're redefining clone, if you can, make your class final. Then no one can extend it. So it is a little bit of subtle. And so one of the things that's kind of dumb is this tagging interface thing. The clonable tagging interface is automatically inherited. And that's almost never useful. And in general, you should probably never have a tagging interface because so the tagging interface is something that someone needs to mix in to say, I want to have this property. And if that property does not automatically extend to subclasses, then interfaces are a bad mechanism for that. But in Java 1.0, they had no other mechanism, so that's what they used. So the TLDR is that tagging interfaces are usually bad. All right, so that's cloning. Now, in the past, I used to make a huge big thing about cloning because all of us who did Java came from C++, and in C++, a value copy is the default. If you have an object and you make a copy of it, you get a brand new object with everything automatically, so to speak, cloned. And if you wanted to share objects, then you needed to use pointers. And those of you who know any C and C++, what do you know about pointers?
They're annoying.
They are dangerous, right? They are potentially evil, and you want to avoid them at all costs. So from a C++ background, it seemed like cloning an object, making a new copy of it, was the desirable thing. And sharing was somehow much scarier. But in Java, if that's what you've grown up with, you probably have the opposite impression that sharing is mostly okay. Once in a while, yeah, it's an issue. But making a copy, that seems like a big and complicated thing to do and maybe expensive. And so probably the Java view, in hindsight, is more the right view. Because we've now had 20-some years of Java, and have a look at how many classes in the tens of thousands of classes in the standard library actually redefine clone. It's a few hundred, maybe 1,000. So cloning is not super common. You would use cloning for things that are genuine value objects, like rectangles. A rectangle is just a thing, and you don't normally want to share references to a rectangle. And so that cloning makes a lot of sense. But if you have other things that you don't normally need to make copies of, like, say, a cube. I mean, when was the last time you wanted to make an element-by-element copy of a cube? Or like an output stream, right? That never makes any sense. Why would you want to have, or what does it even mean to make a separate copy of an output stream? So in that case here, you wouldn't clone. So cloning, it has its role, but it's not as important as the textbooks maybe make it out to be. Now there's a similar and related thing called serialization that has a I put them together because they really have this same kind of flavor. So here's what we want to do, is I have an array of a couple of employees, and I don't know why here it's an array, and here I'm using an array list, that's a typo. So it should say this. Staff bracket 0 is new employee, staff bracket 1 is new employee. Or maybe this should be an array list of employee and not an array. Either way, it's fine. And so now I want to save this data structure with all of its elements out in a file. That turns out to be super simple in Java. I make what's called an object output stream. I need to make a file output stream and wrap it into this object output stream using the decorator pattern. That's the way the libraries works. And now I have this object output stream. I write this object, which is here the array or array list, whatever you prefer, and then I close the stream. Now my file, staff.dat, contains some binary soup that describes this object. And you can do that with any objects that implement what's called the serializable interface. So that's a very nice feature because you can have a complicated object. Yes?
Didn't you say that this was the bane of web-based
Yes.
applets?
Yes, and I will get to that in a minute.
Okay.
But first of all, it is a nice feature. So when you save this thing here, then you have, with a single command, you have now saved a whole network of objects. Let me give you a better application. In Violet, what do you have? You have a bunch of node objects and edge objects that form the graph. All I have to do is I have to take that graph and I say out.writeObject graph. The entire graph, with maybe hundreds of nodes, is now saved onto disk with a single command as a bunch of binary soup. When I read it back in, do I have a? No, I don't. You'll see that in the book. To read it back in, all I do is I make an object input stream. I read with one command. I say read object. I have to cast it to what it is. In this case, an array. In the case of a graph, to a graph. And then I get the whole thing back with all of the connections between the objects preserved. Now that's super convenient. If you had to program that by hand, it would be a lot of work to do that. So it's a very attractive thing that one would want to do. Now, let's see how it's done. So, remarkably, none of the classes have to implement any methods at all for this magic to happen. It's completely automated. All they have to do is they have to implement the serializable interface. Serializable is kind of like clonable, except it says, I'm okay to be written out to disk, as opposed to I'm okay to be made a direct copy of. Because they're subtly different, so they use different tagging interfaces. So how does it work? I'll just describe it with this picture here. Whenever something is saved out to disk, or to the stream of bytes, it gets a serial number, hence the term serializable. So the employee array here is saved, and it gets serial number 1. Maybe 0, but let's say it's 1. Now, what does it have? It has a reference to something that has not yet been saved. So first of all, then this thing is going to be written right after the byte stream. And over here, where there's a record for this field, it can't write in like the memory address, because the memory address is meaningless outside the virtual machine. When you load it into a different virtual machine later, it would be at a different memory address. Instead, it's going to put in, to say, number 2. It's going to say we have an array, which, by the way, has serial number 1, where the 0 slot has number 2 in it. And what's number 2? It's an employee whose name, I'll skip over the name for right now, whose salary, that's a value, so it puts it right in there. And where the buddy field here is number 3. And number 3 is an employee where the salary is also, whatever happens to be the same name. And the buddy is number 2. So there are no pointers in there, they're just these numbers. But the numbers, of course, you can think of them as pointers that link the objects together. Oh, and then also it says, fills in a thing here that says number 3. So it's all done with minor numbers. There's some code that says array of employees, this is the length of the array, and then there are slots that says number 2, number 3, and if the array was longer than that, maybe no, some indicator for a non-pointer. And then afterwards comes this thing that says I'm object number 2, my class is employee, my name is, and I didn't do the name because the name is of course a reference to a string. So somewhere there's a string object that I'm not mentioning here. And this is a reference to some other string that gets similarly serialized. So you have a bunch of binaries to spelling all of this up. When reading it back in, then how does it work? There's some bits here that say this is an array of employees. So the code that reads it in must now construct new array of employees. Then it knows there's 2 elements in it. It's told, oh, this one here has serial number 2. Then it has to find in the stream where is serial number 2. It finds that as this employee. It makes a new employee and fills in these things here. Now, when I said it makes a new employee, I lied.
Oh.
Because it does not actually call the constructor. So normally, when an object comes to life, it comes to life because a constructor was called. And that's what they've told you in object kindergarten, right? The only way to get an object is to call new so that it's properly constructed. And you can be guaranteed that an object has certain properties as long as you set up your constructor or constructors so that those properties are preserved. For example, if you make it so that the salary is never negative in any of the constructors, and it can't be made negative in one of the methods, then you can be guaranteed the salary will never be negative. That is what serialization violates. Because if someone crafts a stream of bytes that contains an employee record, and they just put the bytes for a negative thing in here, and then one calls object input stream.read, then you can now get an object that no longer has the properties that everyone expected. So you can make things that were never properly constructed and therefore can violate some of the invariants that you normally want from classes. So that's kind of bad about this approach to serialization. Yes?
Can't you also, like, in the bytecode, just like make an object that's like really mal.
Yeah, so let's see what else could we do, right? So could we make a class that didn't even exist? Can we make a class Joker? Then what's going to happen, though, is the virtual machine is going to say, well, I don't know what that class is, and it's going to throw an exception. Could you add another field? The virtual machine is nervous about that, and it checks whether those fields exist in the actual class. So you can't really do that. So you're somewhat limited as to the damage that you can make, but you can certainly change the state of the object. So as another example, there may be code that relies on the fact that name is never known. But it's an easy matter to smuggle in and out. And you might say, now, is it an easy matter? And of course it is, because any junior hacker can do this. You just write one out, and then you go in there with the hex editor and make changes. The format is well documented. And even if it wasn't, it took me, 20 years ago when I wrote the first edition of Core Java, and I had to document the format, which wasn't documented, it took me, I think, 2 days to completely reverse engineer it. So any hacker knows how to do this. So the danger is that you can craft objects of existing classes with bad contents. The other thing that makes serialization less useful than one would think is that it's just a matter of time before objects evolve. Someone takes a class and adds another field, or changes the name of a field, or whatever, or changes the type of a field. People do that all the time. And then, of course, the old serialization has become worthless. And the designers of this feature said the primary interest that they had for serialization was not to put something in a file, let it set in the file, and come back years later. That doesn't work because objects evolve. The primary motivation was, what if I have a virtual machine here, and I have a virtual machine there? This one is getting too much work. I want to move all that work over to the other, and have them continue. And then, of course, the objects will not have evolved that quickly, right? It'll still be the same class in both of the virtual machines, and so that one is fine. And that was, at the time, a very common scenario because processors were much less powerful than today, and it was a very attractive application for Java to do this automatic load balancing, where really physically, so to speak, objects were shipped from one instance to another. The other thing is what they sometimes would do is they would say, I'm now going to embark on this computation, but how do I know my machine won't crash? And they would just ship the definition of the work off somewhere else, and when the first machine did crash, it would just be resumed somewhere else. So for all of this fault tolerance, load balancing mechanisms, serialization did seem like the gift from God. And if you do this in a constrained context, it is fine. When I said, why people are mad at serialization, it's that it is a feature that's baked into every virtual machine, and it's baked into the client virtual machines as well. And so hackers have crafted these serialization attacks. There was code that was relying on being able to deserialize objects, and they would feed them bad objects that would then cause crashes later. That would have been an easy way of dealing with that part. They could have built in some kind of trust mechanism. But that was never done. They could have said, we'll make it so that an object first needs to be constructed, and the serialization then invokes some mutators to bring it to some amount of state or something. There's other ways of doing serialization safely. It's just that the way that Java in 1995 came up with this was good for one thing, namely for distributed computing, but it was not good for the kind of secure computing that Java also wanted to be good at. All right. Once in a while it can happen, I'm not sure this is going to happen to us, that you need to serialize something that wasn't previously serializable. There's a way of messing with the algorithm to do that. This might happen to...
It does in Violet.
In Violet, okay, so in Violet 0.16c, I'm using a different mechanism for serialization. I'm using this long-term serialization mechanism where it doesn't use this at all. In the graph editor, it did at one point happen. When you look at the old graph editor code, you might see some things that are transient. Transient means they're skipped by serialization, and then something else gets serialized instead. Now in 1.4, like ellipse 2d.double was for some reason not serializable. And we all fetched about in 1.5 that fixed that. So that might still be left over there in Violet. Nowadays it does not happen very often. It might happen to some of you when like in FX, I guess, if you try to use serialization with FX, you would have to declare some things as transient, and that might help you serialize the rest. You might want to send me an email about that. Also, and I'm a little fuzzy about that right now because that changed at one point. In Android, there is a similar issue. In Android, an application can kind of fall dormant when memory space gets low, and the application just kind of gets kicked out. It gets a chance to store its state, and you can use serialization for it. At least that was true a year ago, so let's hope that's still true. And you should just do that because it's far and away the simplest thing to do. It's a little less efficient than some of the others, but you don't care. And in that case, you might run into some limit of serialization. If this happens to one of you, send me an email, and I'll just point you directly to the intricacies. I don't think everyone needs to know this in 2017. All right, so that's what I have here. Let's see if we can get anywhere with this lab. And at least get to do one of the activities. So this is the slides for, where is it down here? No, did I not? Here. 47475. All right, yeah. So we just want to try out a little bit of cloning and serialization here. So do this with a buddy. Just grab this code here. It does clone. It doesn't do anything. You're going to start to have to add cloning to it. And then it teaches you how to make the deep copy. I think that's all we're going to get to doing today. So go ahead, and that way you'll actually see what I just said, and it'll make more sense to you.